Okay, let's get started. A couple of administrative items. First of all, we have a few things to do with bond settlement. First of all, I think we have one bond which is matured today that Eric owns. You want to present that bearer bond? Okay, so this says, yes, the letter, yeah, that's right. The letter may be presented to Ethan Ligon, check, by the bearer for an immediate payment in the amount of $100, payable on or after November 15th. This all looks in order. Let me give you $100. It could probably be arranged. Oh, oops. Trying to cheat you there, sorry. Okay, I think you'll find that's in order. Okay, there were also two outstanding bonds that have some probability of default. I don't know if those folks are here. So Katie was the owner of one of those bonds. She looks like she's not here today. Was the owner of the other bond? Yeah, that's right. Okay. So which one do you have? At a 1% probability of default? Okay, so I'd like to go ahead and ask, I'd like to ask somebody to roll some dice. Yeah, would you come up, please? Thanks. So Cassie will roll these dice. The deal is these are two 10-sided dice, or two dice, each which is 10-sided. I'm going to ask you to roll these. The yellow one will be the most significant digit. The green one, the least significant. It doesn't matter in this case. If they come up 0-0, then I get to default on that bond. Okay. And otherwise, it'll be payable in full 1 year from last week and so on. Okay, thank you. Maybe you can just roll it on the table here and report the results. Oh, yeah, let's. Okay. Well, the green one says. Yeah, go ahead. Okay, so very good. All right, thank you very much. Okay, and several of you. Several of you came to pick up bonds last Thursday, and I didn't have them. Are any of those folks here today? Okay, so see me after class. I have them today, and I'll give those to you. Okay, so that's what I have for bond settlement, I think. Let's see. Oh, problem set 7. Let me return that. It's in alphabetical order as usual. I've put the statistics regarding performance on this problem set up here. The average grade here is a little bit lower than it has been for recent problem sets. I consulted with Jeff and Elliot. Their collective view is that it's more because the problem set was just shorter, so sort of some rounding error that resulted in maybe fewer A's and B's. I think overall performance on this problem set was not bad. Okay, other administrative matters? Okay, so I have a special protest day sort of talk planned today. So here's a picture of Mario Savio, not the usual one. He's got this famous quote about there's a time when the operation of the machine becomes so odious that everyone knows because it's written up in big letters in the Free Speech Movement Cafe, and so starting here. I actually like the first part of the quote better, so I thought I'd share it with you. So we're a bunch of, he's a little bit, I think he's making this up on the spot. He's not entirely articulate here, but the sentiment is sound. But we're a bunch of raw materials that don't mean to have any process upon us, don't mean to be made into any product. Don't mean to end up being bought by some clients of the university, be they the government, be they industry, be they organized labor, be they anyone. We're human beings, and then the more famous part of the quote begins. Okay. All right, so I wanted to spend some time on a different set of topics than I had planned to today. I planned to discuss externalities beginning today in joint production. That's not what I'm going to do today. Instead, what I'm going to do is spend a little bit more time with some discussion about intertemporal choices and present value calculations. There is, I think, an interesting, if you think that the protests that are occurring on campus today or the organized Oakland events and so on that are going on are related to inequality, that's actually timely for this class because the operation of bond markets and other credit markets is intimately related, you might say critically related, to the evolution of inequality over time. And so I'll have a little teach-in moment today when I talk about that briefly. And it's this general idea about how inequality evolves, whether it's in the U.S. or other countries, is a really hot and interesting research topic in economics generally. I'm just going to have time to say a couple little interesting notes about it. Then we'll get into a comprehensive discussion. But maybe I can make a couple nice points here. And then if we have time, I'm going to return to a sort of continuation of a topic we talked about last time, which has to do with the optimal extraction of natural resources over time. And so that'll be, again, all these things are sort of related to choices that people or firms make about time, when to do things or when to consume things. Okay, so let me start with some present value stuff, or maybe actually let me do that. So I want to give a very simple, just numerical example. I'm not going to try to motivate this as being particularly interesting by relating it to a real world example, and instead just make sure that sort of the mechanics of doing the present value calculations are clear. So we have a general formula for present value that we came up with a couple lectures ago. We said that we imagine. Let me write this up. So suppose that there's a stream of income, and speaking through income broadly here, it could be a stream of income, it could be a stream of savings that happens over time, it could be a stream of dividends, a stream of benefits maybe more broadly, but suppose it's a stream of income over time, which is, I'm going to write it this way, so it's a little set yt, so this is the process. So the idea is that in each period t, you get some quantity y, and that's your income, your savings. So here's an example. Here's different values of t, here's different values of yt. Suppose that in period 1, we get 1 unit, in period 2, we get 2 units, in period 3, we get 3 units. Okay, so that's a very simple process, and so you get $1 tomorrow, you get $2 the day after, you get $3 the day after tomorrow, or 2 days from now, in the third period. So how would we go about computing the present value of that short stream of income? Yes, sorry. Well, okay, so we could add it up. So this is okay. We could add it up. We get the number 6. Would that give us the correct answer for the present value of this thing, though? So it's true that let me ask another question. Suppose I offered you a penny today, and a penny the day after, and a penny the day after that, and so on. So you got a penny every day for forever. What would the value of that stream of income be? How would you go about computing it? You have to know the interest rate. That's a case where we fall into our case of a perpetuity. So I mean, I'm not going to actually auction this off, but how much would you be willing to pay for a penny a day forever? I'd be willing to pay more than a penny, but it'd be like offering perpetuity actually. Yeah. Okay. So if we take into account the hassle of going and collecting your penny every day, that would be probably have a negative value. We'll imagine we set it up as an automatic transfer to your bank account or something to sort of eliminate those transaction costs. Okay. So how much would that be worth to you? I don't know. I mean, more than a penny, I presume. Yeah, so the formula we do this, the formula for perpetuity would say that the present value, so this is a different one. So this is one thing we talked about. Another possible YT that we're talking about now would have 1 penny, forever. So the value of this, we have a formula. We can use the formula for perpetuity would just be equal to the amount of the payment, which is 1 cent, divided by R multiplied times 1 plus R if we start tomorrow, and that'd be it. So if the interest rate right now, actually here's another question that's worthwhile. What should we, if you're thinking about this, trying to solve this problem for yourself, what's the relevant interest rate, you suppose? So you probably can't. I mean, the U.S. Treasury can borrow money on short-term money at 1/100th of a percentage point right now, but most of us can't do that. What do you think? Yeah, well, so these are all that's a good question. So inflation would enter into it, but inflation will affect the nominal interest rate as well. If we think about the usual way we compare these things, we'd say we talk about the nominal interest rate is roughly equal to the real interest rate plus inflation, the inflation rate. But all the calculations we're doing will use a nominal interest rate. So they have the feature of already accounting for inflation. And it's not that inflation is unimportant, but if we're using nominal rates, it's already in there. We get that for free. Okay. So what's the relevant interest rate? How many of you currently have debt? So, student loans, credit cards. Okay. So what's the? You said you had debt. I think. What's the rate? Ashley, I'm sorry. What's the interest rate you're paying? If you don't mind telling us.
It was 2%.
Okay. And can you describe the nature of the debt?
I got into car accident over the summer.
Oh dear. So what are you using? But how are you financing it?
I took out a small loan, but I was using for my student tuition. But I took that actually paid off just for the last few years.
Okay, great. So what was the source of the 2% loan though? Can you tell?
It was through my bank and stuff.
Okay. Okay, fine. So Ashley would, when she's making a decision about whether to borrow or consume, might use an interest rate of 2%. So with a 2% loan here, the present value of a penny per day would be what? So it's 2%. That's 0.01. So it's just 1/2 times 1.02. So that'd be worth 51 cents. Yeah, is that reasonable? So that's actually a penny per year. So it's worth 52 cents at an interest rate of 51 cents at an interest rate of 2%. Is that calculation clear? Yes. So let's come back to, okay, so fine. So in this case, let me write this up. If R is equal to 0.02, that implies the present value for this case, and this is, be careful, I gave the example of a daily penny, but this is an annual interest rate of 2%, I presume. So the example becomes a penny a year. We said that the present value of this is going to be equal to 51 cents. Okay. All right, so that's that example. Let me return to this example now. The suggestion was made to just add these up, which gives us a total of 6. Okay, what's wrong with that? Apologies, what's wrong with that approach to doing that? Yes? It doesn't take into account the opportunity cost of the funds you have. So you get 2 next year and 3 the year after that, but you'd rather have those today, because if you had 6 today, you could invest the 6 today, and you'd wind up with more than 6 over this 3-year period. So what's the value of these things? Well, in the first period, so imagine you get this next period. So the value of this is going to be equal to 1 divided by 1 plus r. The value of this will be equal to 2 divided by 1 plus r. Divided by 1 plus r squared, and 3 divided by 1 plus r cubed. So the total value of this thing is going to be equal to, here's the formula we've used before. It'll be equal to t equal 1 to 3 in this case, of 1 over 1 plus r to t all times yt, which in this case is just equal to t. So I've chosen yt, so it's equal to 1 in the first period, 2 in the second period, 3 in the third period. So the value of this is just 3. So this is the expression for the present value of this particular flow. Yes. So this is right. So this part is equal to yt, right? Is that the question? Yeah. And this, maybe I should write larger. Yeah. This t is the exponent. Yeah. Yes. So you're asking. So that's the question. Do you see how these add up to this? Okay. So the question is why these 1 plus r show up here. Okay. Let me try a different calculation for you. Okay. So let's suppose that v is the present value of this stream of income 1, 2, 3 that we just described. Okay. And let me ask you, the question you want to ask is this. If you have v is not the present value, that means that it's the present value of the stream is like having v today. Now, if you had v today, I'm sorry. I beg your pardon. Yeah, I'll just write on the board. I'm not going to say anything more, okay? Yeah. Maybe I should change the letter. Is there anyone named... yeah. I think we go with x. So there's nobody goes by x in the room, is there? Yeah, so let's let x be the present value of the sequence 1, 2, 3. And so suppose if you had x today, then you can imagine investing it today. So let's again think about investing it over the course of 3 periods. So we'll have again periods 1, 2, 3, and the value of investing x over this period would be the value of investing this initial quantity x. In period 1, you have in period 1 you get back x times 1 plus r because we would have invested it for 1 period, and so earned interest on it for one period. So if you were, in the case of the bonds, like when you were purchasing bonds, you were like lending me x, and Eric just did this. He invested 99.56 and got back 1 plus r times that quantity for a total of $100. Okay, so you get back this quantity here. In the second period, what would you get back? We're going to imagine, so we'll imagine reinvesting, the returns on this investment. So we'd have x times 1 plus r squared, right? Because we get to earn interest on last period's interest, and in the third period would have x equal to 1 plus r cubed. Okay, so that would be the value of an initial investment x. over time. This is rather the y's that we get out. So this is like the yt's we get out of this thing. So we have we have yt equal to x. We're just rewriting this 1 plus r plus in the second period we have 1 plus r squared, and then in the third period we have 1 plus r cubed. Okay, so if this is the yt's we get with an initial value of x, the present value calculation we want is to imagine now. I'm sorry, I did this incorrectly. So if you had an initial value x, you could get this stuff. So that's right. So we want to compare this stuff now to a flow, which gives us. Let's see if I can get this right. I'm sorry. Let me back up. Keep this. That's what we got if we invest x. Erase this. It's repetitive anyway. We want to compare this to our yt, which is just 1, 2, and 3. All right. So we want to find the value of x that makes the value of these two flows equal. So we want to find x times 1 plus r plus x 1 plus r squared plus x 1 plus r cubed.
Hello, this is a friendly interruption from the Strike Committee of the General Assembly of Occupy Cal. We have a short statement and ask for your quick votes.
Hello, students of microeconomic theory. We're here to make a proposal to you. Because the governance of the university is flawed, we believe the only solution is the complete integration of students in the democratic governance of all educational institutions, beginning with our university. Today's general strike and open university marks are reasserting the right to shared governance of our collective learning space and direct influence in our quality of education. Right now, we can exercise that influence by taking a vote on whether or not to move our class outside, if we choose not to cancel it. Out of respect for the open university, we insist that class be moved outside to facilitate inclusion. So we're going to go ahead and take a vote.
You want to move your study session outside to install
Yeah, excuse me. Yeah, so the students who are here today chose to come to class. They're free to leave if they wish, and we appreciate your coming by to share your message.
Anyone who wants to come outside, please feel free to join us, and the rest of your university and the rest of your town of Berkeley. We're outside on Sproul. Hope to see you out there.
Okay, so let's compare the value of. I'm sorry, I'm messing this up. Okay, so here are the stream of dividends, the y's that we get if we invested the x initially. We want to compare that to this stream of dividends. So if we got this stream of dividends, what could we do with it in terms of investing as we went along? We get if we just invested it, what we get is in the first period we have a total quantity of 1. If we chose to invest that, then in the next period we could get back some returns of some returns. We have 1 in this period. In the next period we have 1 times 1 plus r plus we have this 2 that we get. In the third period we could invest this 2. We get returns on our 1 plus r. So we have 1 plus r squared plus 2 times 1 plus r. And then we'd also get an income of 3. And so that would look like the total amount of stuff we wind up with. Let me talk through that again. So this sort of column of stuff are the returns you get from investing this initial quantity 1 in period 1. So you get 1 in the first period. If you choose to invest it, you wind up with 1 plus r in the next period. And if you keep that same 1 invested, you have 1 plus r, but you weren't interested in it again, so you get 1 plus r squared in the third period. So this column is just the returns you get on the initial investment of 1 here. In the second column, you get 2 in the second period. If you choose to invest it, next period you have 2 times 1 plus r. And then you also get, though, a payment of 3. Yes, Scott? Yeah, exactly. That's exactly right. And so you can see. So here, what I'm doing is multiplying by r because this is how the value of your investment accrues as you earn interest on it. And so in the final period, you have a total payment that looks like this. So this is what you get in the third period. Now here's the calculation. You only get this 3 periods from now. So this is the amount of stuff you'll have in 3 periods if you follow this sort of scheme. But what's the present value of this quantity of stuff from the standpoint of period 0? You're only getting this quantity of stuff 3 periods from now. If you had it today, you could invest the whole thing. You'd like this quantity x. But you don't have it all today. This is just what you get 3 periods from now. Let me ask you a different question. If you receive a payment, let's call it z, cap t periods from now, what is present value? So this is not a stream at all. It's just a one-time payment of z t periods from now. Close. So z, yes, very good. So z divided by 1 plus r to the cap t. That's exactly right. So we're talking here about a payment that you can get in 3 periods, and this is the quantity. So the present value of this is equal to 1 over 1 plus r raised to the third times this stuff. Okay, so that's it. And then, let's see. I'll go back over here. I just want to multiply this factor through. So I got 3 1 over 1 plus r cubed, 1 plus r's. So if I multiply that through, I wind up with a 1 over 1 plus r. That's its first term. I have 1 plus r squared divided by 1 plus r cubed. I have 1 over 1 plus r. Plus, I have 2 divided by 1 plus r squared. Plus, I have 3 divided by 1 plus r cubed. And that looks a lot like the sum we wrote down to begin with.